Hello, everybody. I am Justina. I work in Terrasolid as technical support engineer. And today I will talk about final products using DJI L1 data. So first of all, a bit about Terrasolid software. The software is able to process large-scale projects, but it has also simpler version for UAV users. Also, some development quite recently was done particularly for DJI L1 users. And now Wizard is available for automatic data import and classification. This is today's webinar agenda. So we had already quite some webinars and training presenting the workflow with a wizard, how to import everything and how to classify the points. Today I will concentrate on the final outputs from the classified point cloud. So first of all, I will talk about elevation model creation, and when you have that created, additionally contour lines can be exported, analysis for drainage, and as well volume computation. Alternatively, raster can be exported as a elevation representation, and my last examples will be related with vectorization, so Powerlines vectorization and building vectorization. About elevation model creation, so in TerraScan it's called Lattice model export. The tool creates a gridded file with the values of elevation, and additionally TerraModeler can add also breaklines to the model to have even more precise data. As well, when you create a surface model, software can produce contour lines. And it's possible to change the settings, also to simplify a bit those contour lines. You can manage the details and also put the labels or without it. Here you can see example of the analysis for drainage, and also there is a tool to compare the two surfaces. So for example, the bottom of the pile and the top surface, and to compute the volume of that pile. As I mentioned, there is also ability to export raster. In that case, the image will be colorized according to, for example, intensity or elevation values. When you have already classified data, it is enough to use just wizard classification. The segmentation logic will also classify the building roof, and this can be used for building vectorization. And my last example would be about power lines, how power lines can be vectorized and also classified at the same moment. Now I will move to demos of these examples, and we can see how things are happening in the software. So first of all, I will go through export Lattice model workflow, more like a demonstration. Here I have already classified point cloud. It was classified with the wizard. So here you can have you have new drone project tool and as well process drone data. So if you take everything, basically you get this result. And segmentation logic also classify some objects as buildings, cars, separate trees. For surface model, I will use just ground surface. So here I have the result of ground classification. Before starting the export of elevation model, you can check as well if there is no mistakes in ground classification. It is possible to use either editable model or just simple display mode by shading. And then if you see some bumps in the model, it could be you can have a guess that maybe something wrong there. So if I do the section, I see that some points on the object were classified. It is possible to exclude that from the ground. And then shaded model was updated as well. Let's say it is the final result of a ground classification, and then the lattice model can be exported. So lattice model, it creates the gridded file where each point stores XY coordinates of the point and as well the possible values for the third one. So either the elevation values, point count or density, or more analytic values. If you choose, for example, lowest hit Z, then the lowest elevation value, which is covered with this pixel, will be written for that point. The grid spacing defines the distance between grid points, and also this is kind of the resolution of lattice model. Filling the gap, so it defines the size of gaps that will be filled up with the pixels, and also the value will be taken from closest point in the source class. Here's available formats for the lattice model, and when you create, you can either demonstrate it in TerraScan, reading geotiff, and presenting as a shaded surface, or if you are using another software, it can be simple attached and it will be in the right location as it's georeferenced. So from this elevation model, I can see that some gaps they were they weren't filled with the pixels. Here I had 2 buildings, so 3 wasn't enough for the filling gaps. Another possibility is to export Lattice model and to write the elevation value from a triangulated model. In this case, the gaps are described with the maximum triangle size, and it affects how big gaps are filled in with the lattice model by interpolating grid. And if I check what result would be from triangulated model, so now I have the model without gaps as previous. One more alternative for creating the surface model is creating the surface model in the beginning and then exporting from the TerraModeler. So this tool, it requires loaded TerraModeler application, and basically this command just passes the selected points to TerraModeler application. You can check created surfaces and TerraModeler surfaces dialog. So here I see the one that I just created. And if I want to see how does it look, display shaded surface would do it for me. So I will take from the display points out. And now you can see displayed surface model. The export of the model can be done as well from surfaces dialog and then export and lattice model or other needed formats. Additionally to this, in case you have like a breaklines of buildings, or in this case I have a lake here. So if I would need to use the breakline, it can be inserted. So I need to select it and then insert breakline element. So it will use additionally those points to my surface model. If you use the breaklines, those must be dropped to the surface elevation first. So if you vectorize something on 0 elevation, then you would need to drape it. So instead of new surface, I will edit the existing one. And then this model would follow the breakline information. To check it's something new, There is also possible to define the extent of the surface model, and then when you export, export not the whole surface, but just for example selected rectangle. And as well you can choose the format, no data values, to create additionally TFW file. And if you place some text inside, it can be named according to that. So this was about elevation model production. Also, when I have a surface created, TerraModeler can produce the contour lines. It can be either done as a temporary ones, so I can just display those and write into the file. At the moment they are quite detailed. It is also possible to use classification routine and to classify contour key points. Then the software would choose like the points where the relief is changing and use only those for the contour production. So for example, if I create another surface model from those classified points, it will be simplified. As you can see, like the amount of points is also different. So the source, it's not so detailed. And then if I produce from the contour surface, then as you can see, it is much simpler. Yeah, so this is the result of classified contour points. I will get rid of contours, and then I will move to a quick demonstration of drainage display. So again, you need to choose for which surface you produce this display, and then this is the result. So you can manage the viewing details. This display shows the paths, how the water would travel. The arrows show the direction, and the line width gives indication how much water would travel. As well, the red squares mark places where drainage water would gather. All this can be drawn into the design file, so that result can be shared after. Now about volume computation. So you need again to have the surface elements, and similar as I showed how to create the surface for ground points or the contour points, you need to do the same for the ground surface, or use already created for the ground surface, and then to have like theoretically the bottom surface. It can be done, triangulation of that surface can be done from the line around the pile or around the object that you want to calculate the volume. And when you have two surfaces, like the bottom and the upper surface, then compute quantity tool would do a job. So here you select what is the upper surface, what is the lower surface, and then software calculates and display the volume of the selected pile. As I demonstrated before, the surface export as a lattice model. So in that case, we saw the gridded file, which, for example, QGIS was coloring according to the pixel value as that file. It is possible also to export raster image. So in this case, you can choose also what kind of value will be written in the file. So XY coordinates of the point, and then additionally the value. Just in this case, not the value will be written, but the color according to the value. And then as a export file, you would have a TIP file already colorized. The next example is building vectorization and Powerlines vectorization. So I will start with Powerlines. Here's the small data set that has a couple spans of Powerlines. So TerraScan has tools for Powerlines. Detecting wires or place catenary string would place the vector along the wires, and as well would classify point cloud, classify the points of wires to another class. To use this tool, it is recommended to pre-classify point cloud in the beginning. So at the moment, I have point cloud distributed into 3 classes according to the distance from the ground surface, and mostly like the wire points goes to high vegetation class or to the class which is more than 5 meters above the ground. not to overload the step of detecting wires with the amount of data. As I mentioned, it is recommended to do a pre-classification of potential wires. So first of all, you need to have guideline as a tower string, the line which would have would go like in the center of the power line, and as well to have nodes on the towers. So the same line can be used to do a pre-classification of potential points, and as well later to use it to detect wires and to vectorize those. The pre-classification can be simply done by center line. So I have that vector element here. I select it, and then there's a classification routine by center line. So I check, like, I would like to classify from high vegetation to model points. Those would be my potential wires, and then by selected linear element. I see that most points went to that potential class. There's also some vegetation around, but the detection, we can check how it works, this detection. To start the tool, first you need to activate the power line. So the same center line should be selected and activated. It will turn to a bright yellow color. Then detecting wires tool would draw the vectors into the design file, and as well to do the classification. So in the first section of this setting dialog, you need to choose from which class to which one you want to classify. So in this 8th class, I have my potential wires, the blue points, and I would like to classify to the wires class. Apparently, I don't have it, so you can add or modify the classes in the point classes. And when you modify or already have, we'll come back to the same tool. So now I choose that I want to classify from the potential wires to the wire class. And it can be either done for all segments or for the single one. So in this data set, I have just single one. I will detect just for this one. I see that detection and classification of wires happened quite well. So if I display just wire points, I see that all 3 wires were detected. Just for one, the vectorization didn't happen well. Probably I would need to go again and to check the settings. But in case you have quite noisy data and the automatic vectorization and classification doesn't work so well, there's also possibility to use the manual tools. And as I mentioned, this detect wires, at once it draw the vector lines. So those were drawn into the CAD platform. So it can be cancelled. The vectorization can be cancelled with just undo from the CAD platform, and a point classification can be and then from the TerraScan dialog. If you do manual vectorization, then preclassification, as I did for automatic tool, is not necessary. The vectorization is done from the side view. So here I have the side section, and then again the power line should be activated, and then instead of detect wires automatic way, we can check place catenary string, the manual one. And the tool is also in the toolbox. So it was as place wire string, the manual one. So I will do the section again. And then the tool gives you a choice to start the location separately. So either you want to click in the ends next to the towers, or you can do it with the just 3 clicks. Then you choose to which class you're snapping. And I still have my potential wires in class 8. And then it's the same one for fitting. And I have the separate class just for wires. So again, after the vectorization will be done, the points around that wire will be also classified to the wire class. So 3 points identifies the parabola, and then you finish the vector. I will display again in my top view just wire class. So you can see that along this element that I just vectorized, the points were also classified. And now I have the vector and the classification done. Later, these vectors can be exported, used for simulation, or as well used for dangerous vegetation detection, for example. So this was about Powerline. Now I will come back to the classified data to check building vectorization. So for building vectorization, it is enough just to do classification from the wizard. In case you want to have something more detailed, then you can improve that. But I think that just classification above ground features is okay from the wizard. I have building roofs in class 6, and it will be used for building vectorization. So the tool is in vectorize buildings in the building menu, or from the toolbox, this one. It asks the user to choose the roof class. So this is like the main class used for the building vectorization. And then to pick the lower classes, like below the roof. Also the settings for details and tolerance. And after I approved the settings, I got vectorized buildings. These are 3D building models based on loaded points, so on building roofs. And this tool creates microstation cell elements that contain shapes of each roof plane. And those vectorized buildings later can be used for textures as well. So if I rotate the point cloud, I see the 3D view, and this would be the models for the buildings. This example ends my presentation of today's topic. Thank you for your attention.